Welcome to this video in our course Competition Policy and Strategy. This video is on exercise 5.2, so the second exercise on the assignment number 5, and we are going to talk about market power once again. This exercise, as it says in the exercise text, is very closely related to the previous exercise, exercise 5.1, right? So we are asked to proceed from the information, from the assumptions we made in exercise 5.1. So in case you have not yet listened to the solutions or have not yet fully understood the solutions of exercise 5.1, I would strongly recommend to going back to that exercise first before watching this video and before trying to solve this exercise. All right, with that out of the way, let's have a quick reiteration, quick recap on what model we are actually looking at. So we are faced with a Cournot oligopoly with n firms, where n, this is the whole point of the exercise, is kept as a parameter, and at least until now we did not consider, we were looking at how the market outcome, how the welfare, how consumer surplus changes with changes in the number of firms n. Alright, we furthermore assumed that we have a homogeneous good in the market, and we also assumed that we know the linear demand function, which is Q as a function of price equals 250 minus P. Then finally we assumed that all firms are facing the same constant marginal costs of C equal 100. Now in task A we are somewhat making the exact opposite of what we did in exercise 5.1. Because in exercise 5.1 we were considering a situation where we knew the fixed cost, and then we're asking, well, how does the market outcome look like under free entry? How does the fixed cost affect the number of firms in the market? Okay. In this task A, however, we are doing kind of the opposite. We are now asking ourselves, well, let's just consider any parameter f for the fixed costs and assume that there's two firms in the market in equilibrium. And then we are asking, well, what value would the fixed costs need to take in order for this, so n equal 2, to be the actual market equilibrium. All right, so for a given number of firms in the market, what fixed costs are needed in quotation marks in order to make this the actual market equilibrium? Okay, so let's first conceptually think what needs to be true for n equal 2 to be the market equilibrium. All right, and the way we want to approach this is that we want to find the fixed costs so that n equal 2 is the actual market equilibrium. So we want to find the level of fixed costs so that the profits of each firm in the market is equal to 0, at least in the first place. All right, so let's, in the first step, remind ourselves that we already discussed in the previous exercise that the number of firms in the market under free entry is defined, or is defined by the condition that is lined out in this first bullet point, namely that the profit of each individual firm needs to be 0. Previously, we argued that, and this is again just to reiterate, we previously argued that as long as there is positive profits to be expected from a firm that is thinking about entering the market, well, as long as these profits are positive, a firm will enter the market. And this will happen until there is no longer positive profits after entering the market. So considering the number of firms after the entry of the market. Okay, so as soon as this condition is true, so as soon as the profits in the market for any given number of firms is 0, this means that we have reached an equilibrium, and in the sense that this is the number of firms that will enter the market, and there will not be any additional firms in the market. Okay, so what we know from this is what we can use this for is that we can find an expression for the fixed costs as a function of n that provides exactly this condition where the profit is equal to 0. All right. Now, where do we get this from? In order to understand, or in order to grasp this formula, we would have to take a look at the previous exercise. Let me just move backwards a few slides, in which we defined the profits as a function of the number of firms in the market. Where is it? It's down here. So again, this is exercise 5, the solutions to exercise 5.1, the previous exercise. So we have found the firm's profit as a function of the number of firms n and as a function of the fixed costs, capital F. We can now use this profit function in the exercise we are talking about right now. There it is, right? Simply by getting F on the one hand side, we can express this condition pi I equals 0, we can rearrange this expression so that we yield a function f as a function of the number of firms n, which is equal to this expression, 150 divided by n plus 1 all squared. Okay, so now we have a function that expresses, well, really what value the fixed costs need to take, or can take at most, as we will see in the following, in order for this number of firms n to be the market equilibrium. Okay, so with this formula we can then move forward and find the amount of fixed costs such that there is less than 3 firms, or just less than 3 firms, but at least 2 firms, all right? And that is conceptually what is written in the second bullet point, okay? So we want to find in order to find the interval of fixed costs for which there is exactly 2 firms in the market, we have to find out, well, how large can fixed costs be at most, so that 2 firms can still sustain being in the market, and then the other end of the interval of this fixed cost is defined as how large need the fixed costs to be in order to no longer sustain a 3rd firm in the market. All right, that is why we need these 2 borders. So the value of fixed cost that would sustain just 3 firms and the value of fixed cost that would just contain 2 firms in order to find this interval. All right. So we need to find the value of a fixed cost so that 3 firms are in equilibrium, and we need to find the number of firms so that 2 firms are in equilibrium. Well, luckily we already found a function that provides the fixed costs for which this no further entry condition, pi equals 0, holds, right? We already found this function, it's written on this slide. So we can now plug in these values for n, 2 and 3 into this function and find out the results written in these 2 bullet points that I'm highlighting right now. All right? We can then find out that for there to be exactly 3 firms in the market, fixed costs would need to take a value of 1,406.25, and for there to be exactly 2 firms in the market, fixed costs would need to take a value of 2,500. Now these 2 numbers, as I outlined earlier, define the interval for the possible values for the fixed costs so that there is exactly 2 firms in the market, right? Because fixed costs just to reiterate, need to be just larger than this value that arises for f of 3, and they at the same time fixed costs can be at most equal to the value that arises for f as f of 2. Okay, this all is summarized in these final 2 bullet points. So for f, for fixed costs that take the value of 1406.25, or for f equal to f of 3, 3 firms can earn 0 economic profits. So that means that at this point, for these fixed costs, a third firm would enter the market. That of course means that the fixed costs, so that n equals 2, need to be larger than this value, so that the third firm can just not sustain entering the market. All right? And at the same time, the lower end of this interval, of course, is defined by f of 2, which is the fixed costs which are the highest possible value for which 2 firms can still make 0 profits in the market. All right, and with that, we have found the answer to this task. And that is the fixed costs f need to be in this interval precisely. So f of 2 needs to be greater or equal than f, which needs to be greater than f of 3. All right. In the next task, we are doing essentially the same. We are just framing it differently, just to be aware of what this means conceptually, right? In the next task, in task B, we are asked to calculate a value of the fixed costs, capital F, so that welfare is higher in the monopoly than it is in a duopoly. So what we essentially want to do is we want to find f so that welfare as a function of n, as a function of the number of firms, so welfare of 1 is larger than welfare of 2. Okay? We have, of course, defined welfare as a function of n previously, so we can rely on those results when we want to find a function of welfare that depends on the number of firms and the number of fixed costs at the same time. Okay? So let's start by stating the function for welfare which depends on these 2 parameters of interest, n and f. Again, we can go back to exercise 5.1 where we were calculating welfare, where we kept n as well as capital F as parameters in the model so that we can state welfare as a function of these parameters. So this result is simply drawn from exercise 5.1. All right, so we can express with the welfare in the market as a function of the number of firms and the fixed costs that each individual firm has to enter. And just to clarify, this first part is the consumer surplus as a function of the number of firms. And of course, the consumer surplus itself is independent of the fixed costs. Fixed cost is only incurred by the firms. So this is why the second part is maybe particularly interesting. The second part of this equation then captures the profits of the firms, which then in turn, of course, depend on both the number of firms as well as the fixed costs. Okay, now with this formula, we conceptually do the same thing that we just did in the previous task, right? In order to find a value for the fixed costs so that the welfare is larger for n equal 1 than it is for n equal 2, we have to find these boundaries exactly, right? And then make a statement on the interval of the fixed costs within these boundaries, okay? So, right. So we can start by calculating the welfare in the market for exactly 1 firm and the welfare in the market for exactly 2 firms. And then for a varying parameter n, we need to find at which point exactly, for a varying parameter capital F, we have to find at which point exactly the welfare for two firms in the market becomes just more than the welfare with one firm in the market, or just less, okay? Now, how do we find this kind of tipping point where the value of a function, of one function, is just larger than the value of another function? Well, we can of course simply find the intersection of these two functions, okay? So we define first the function of welfare for one firm in the market for the monopoly, so n equal 1, and with capital F still as a parameter, so the function for the welfare with one firm in the market as a function of the fixed costs in the market. And then in addition we find the function for welfare for two firms in the market, so n equal 2, as a function of the fixed costs as well, similar to what we just did. All right, so now we have these two expressions, w of n equal 1 and f on the one hand, and then on the other hand we have w of n equal 2 and f. Okay, now in the intersection of these two functions, of course, we find exactly the value of f for which the welfare in monopoly is just larger than the welfare, or mathematically speaking, where the welfare in monopoly is exactly equal to the welfare in the duopoly, right? So, and then of course we know the boundary for the interval of fixed costs for which this statement that we initially need to find, namely the value of f so that welfare is higher in monopoly, for which this statement then is true, okay? So, by setting these two functions equal and solving for f, we can find that the welfare in the monopoly and in duopoly is exactly equal is if the fixed costs take a value of 1562.5. So this is the intersection of these two functions. This is the point where welfare is exactly equal. Then what we next need to see is that for any fixed cost that is larger than this, welfare in the duopoly will decrease. Now, we can either find this or understand this mathematically by calculating the derivative of the welfare function with respect to capital F. And we will realize that because capital F, again, it's only in this last bit of the welfare function, so the derivative of this welfare function with respect to capital F is negative, all right? So for any n with increasing, for any positive n that is, with increasing fixed costs, we see a decrease in welfare, all right? The other way to conceptualize this interval, or to understand how this interval now is defined, giving this intersection point, is by remembering what we discussed earlier, which is the duplication of fixed costs. So conceptually, the duplication of fixed costs, of course, has a negative impact on welfare, which, bottom line is the same, provides us the same direction of the effect, of course, right? For increasing number of firms, for increasing duplication of the fixed costs, we should see, at least in this partial effect, a decrease in welfare, all right? So, we know the intersection point where the welfare is exactly equal, and relying on the argument we just made, we can then state that for any fixed cost that is smaller than this intersection point, we see that welfare is larger in duopoly, right? So this conceptually, just to make the point that we just did complete, for any fixed cost that is smaller than this value f star, we see that this duplication effect, this fixed cost duplication effect, is not yet outweighed by the increase in consumer surplus that comes with increased competition. moving towards a duopoly. All right. So bottom line is, for any fixed costs, for any number for the fixed cost that is smaller than this intersection point, we see that welfare is larger in the duopoly. So the increase in consumer surplus through the competition is larger than the cost saving from reducing the fixed cost duplication. Okay, so this, of course, we have found the answer to the question. Calculate the value of the fixed cost, capital F, so that welfare is higher in monopoly than it is in duopoly. Well, to answer this question, we would say that as long as fixed costs are larger than F star, then the welfare is larger in monopoly.